So this is going to be a continuation of the 6.2 and 6.3 notes, properties of parallelograms. This time we're going to focus more on using coordinates. The objectives are I will be able to prove that a set of points forms a parallelogram in the coordinate plane. If you're a little confused why that's a number 3, go back to the other 6.2 and 6.3 notes and you'll see that was point 3. So we're given some points here. The following are coordinates of the vertices of quadrilateral ABCD. Determine if the figure would be a quadrilateral, would be a parallelogram. Explain your answer. So first things first, let's take a graph and let's actually plot these 4 points. So we have 5, 7, 13, 7, 10, 3, and 2, 3. So whenever we connect the dots, this looks like our standard parallelogram. But we're going to show this using 3 different methods. So we need to determine it by 3 different methods. The first one's going to be the slope formula. So the slope formula is important because opposite sides are parallel. You should remember that from the last set of notes. This is the definition of a parallelogram. We also need to remember that parallel lines have equal slopes. So we've done a lot of practice on this throughout the year. So let's take a look at these points and see if they do have parallel slopes. Or sorry, if they have equal slopes and parallel. So we have A, B, C, and D. So is AB parallel to DC? We use the slope formula. So the slope formula is rise over run. So we said it was y2 minus y1 over x2 minus x1. We've also been using y1 minus y2 over x1 minus x2. So let's use that for A and B. So I have x1 y1 and x2 y2. So let's first look at the slope of AB. So I'm going to use my calculator here. Sorry about this. All right, there we go. So we're going to hit alpha y equals enter to get our fraction bar up. Y2, 7 minus y1 over x2 minus x1. That's 13 minus 5. So the slope is 0. So slope of AB is equal to 0. What's the slope of DC? So now I'm going to have a new x1, y1, x2, y2. So again, we do alpha y equals enter. We're going to have 3 minus 3 over 2 minus 10. And again, we have 0. So the slope of DC is 0. So is AB parallel to DC? We can answer that question, and the answer to that question is yes. We also need to verify that AD is AD parallel to BC. And I want you to try this on your own. So what we're leading up to If it is, then it's a parallelogram. If it isn't, then it's not a parallelogram. So you don't need to write this down. What you need to write down is what the slopes of AB and BC are, and ultimately, is it a parallelogram, isn't it a parallelogram? So let's take a look at the next thing they're asking us to use. They're asking us to use distance. So using distance. So the thing that we need to remember about distance is the opposite sides of a parallelogram are congruent. So if we determine that the opposite sides are congruent, we have a parallelogram. So I already have it graphed out here. Is AB congruent to DC? This is easy to do. Since we have the graph, we can just count it. We can also use our distance formula, but it's much easier whenever we graph it. So we have 1, 2, 3, 4, 5, 6, 7, 8. So it's 8, and DC is 1, 2, 3, 4, 5, 6, 7, 8. So the opposite sides are congruent there. So is AB congruent to DC? Yes. The other thing we need to answer is AD congruent to BC? Well, this one we can't simply count because it's a diagonal line. But what we can do is we can use the Pythagorean theorem. So we have 1, 2, 3, 4, 1, 2, 3. So we have 3 squared plus 4 squared is equal to c squared. Remember, we're looking for the hypotenuse, right triangles. And you should know that c is equal to 5. It's a 3, 4, 5 triangle. Well, let's check out BC and see if we get the same answer. 1, 2, 3, 1, 2, 3, 4. Well, that's 3 squared and 4 squared again, so we have the opposite sides there are congruent. So the opposite sides of the parallelogram are congruent. So going back to our question, or our statement here, determine if the figure would be a parallelogram, explain your answer. We can do that. We can say the figure is a parallelogram since the opposite sides are congruent. So there's our explanation. The last way that we have to show that if this is a parallelogram is by using the midpoint formula. So we have to use the midpoint formula. When would we use this? Well, we have to remember a property of parallelograms. The diagonals bisect each other in a parallelogram. So that would mean whenever I have the diagonal AC and the diagonal DB, they better intersect in the same point. So, what is the midpoint of segment AC. That's one of my diagonals. And I have to use the midpoint formula. So the midpoint formula, I think, is the easiest one to remember because it's just the averages. Whenever we see this word mid, again, we should be thinking middle, average. The formula for average is just you add them up and you divide them by 2. That's the average of x's. We do the same thing with our y coordinates. We add them up and we divide them by 2. So I'm finding AC. So this would be my x1, y1, and this would be my x2, y2. So I get my calculator out again. And let's start off by finding the average of x's. Alpha y equals enter. My x values are 5 plus 10, and I divide that by 2. So that's 15 over 2. I can also turn that into a decimal if that's easier for you, which is 7.5. The average of y's, alpha y equals enter, is going to be 7 plus 3 divided by 2. So I get a midpoint of 7.5 and 5. So what was the average? It was 7.5 and 5. And then I need to figure out what is the midpoint of the other diagonal, which is DB. So I have a new x1, y1, and x2, y2, so we'll call D x1, y1, B x2, y2. So we take the average of the x's, so it's alpha y equals enter, 2 plus 13 over 2. And we see that's 15 over 2. We already said that that was 7.5, so that checks out. So we have 7.5 for our x value. What's our y value? Alpha y equals enter, 7 plus 3 divided by 2, 5. So we see that we have the same midpoints. So whenever we're determining if the figure is a parallelogram, yes, we're going to explain our answers. So the figure is a parallelogram. Because diagonals have the same midpoint. Which means they bisect each other. And that's it. In this video, we showed ways that we can figure out if we have a parallelogram using the midpoint formula, distance, and the slope formula. I hope that was helpful.